Okay, so we have to differentiate the following four functions. So we'll start with A. So we need to take the derivative of negative 3x to the 7th, which is, by that last rule, the constant rule, we can pull this guy out. So it's negative 3 d dx of x to the 7th, and that is negative 3 d dx of 7x to the, oops, I went too far. So d dx of x to the 7th is 7x to the 6th. And of course, negative 3 times 7 is negative 21. X to the 6th. For B, that is d dx of 5 times the square root of x. Pardon me for a second. So this will be equal to 5 times d dx of the square root of x. So this tells me that I need to differentiate the function square root of x with respect to x. Now we know what that is equal to, and that comes from example number 4 in section 1.3. So example 4 in section 1.3. So you go back and look at that, and you know how to differentiate this. So this is going to be 5 times 1 over 2 square roots of x. And so this will be equal to 5 over 2 square roots of x. That is our dy dx if we said this was y is equal to 5 square root of x. If we said it was z is equal to 5 square roots of x, then this would no longer be dy dx, it would be dz dx. Okay, so we have to be a little bit careful with our variables. You'll get used to this notation, like I said, as we go through. C, we need to differentiate with respect to x, because that's our variable. 8 over x. We can pull the 8 out. And so we have d dx of 1 over x. And now this differential was example number 3 from the same section, 1.3. So we know that this is 8 times negative 1 over x squared. So that gives us negative 8 over x squared. And of course that would be dy dx if we said that y was equal to 8 over x. Now, for D, it's assumed that a is a constant, just like 6 is a constant. So we have d dx of negative 6 times a times x squared. So that's equal to negative 6a d over dx of x squared. And we know by the power rule that this is negative 6a times 2x, so that gives us negative 12 ax. Again, a is assumed to not be a variable here, but to be, it's not varying, it's the thing that's staying constant.